All right, everyone. So now that we talked about formulating hypothesis, let's talk about defining rejection region. All right. So let's say we have um, this claim that average income of individuals in the U.S. is $30,000. Mu equal to $30,000, and we assume that mu is uh, the person is not lying, so mu is going to be h0 at 30,000 versus mu not 30,000. So the way I'm going to test this is this. I'm going to say, you know what, I'm going to talk to several people, collect data. If X bar or sample mean is around 30,000, I'm not going to reject this. There is no reason to reject it. But if it is far smaller than 30,000 or far bigger than 30,000, then I'm going to reject it. So that region far smaller than 30,000, this is how I define it, 29,500 or bigger than 30,500. Then I'm going to reject H0. Otherwise, I'm going to fail to reject H0. All right, that is a rejection region. The red region you see there, it's a rejection region. Now, if you collect data and X bar is 29,600, all right, um, it is within do not reject region, so I'm not going to reject H0. And if it is, roughly speaking, all right, so roughly speaking, because we need to also look at S as well. And if X bar is 97,500, then I'm going to reject H0 because it's far bigger than 30,000, all right? It falls in rejection region. Now, let's talk about errors. Is it possible for X bar to fall in rejection region if mu is equal to 30,000? Yes. If you even if your mu is exactly 30,000 and your sample is in a way that completely randomly X bar is very very small or X bar is really really large, then you are going to reject a correct H0. All right, that is type 1 error. And then you have the same thing with type 2 error as well, but I'm going to leave that to you to explore it. All right, now type 1 error is a probability that we are going to reject H0 even though H0 is true, right? In other words, mu is 30,000, H0 is correct, but we reject it, meaning it falls in the rejection region. Now, which one of these two has um, smaller probability of type 1 error? Well, um, if, for example, I collect a sample, mu is exactly 30,000, I collect a sample, and X bar becomes 29,000. All right, remember, 29,000 exact. Now I have two different rejection regions here. One of them is a 2950 less or 30,500 higher, and the other one is a little bit wider. The blue one is wider. All right. Well, if I go with the red one, I'm going to reject H0, even though it is correct. If I go with the blue one, I'm not going to reject H0, right? So this gives us an indication that um, red one has a larger type 1 error, right? Why is that? Because the blue one, rejection region, the boundaries are far from each other, and we are going to reject less frequently. In other words, H0 and alpha is smaller here, right? So type 2 error, this is optional. I'm going to move forward. We talked about all of this. Now, this type 1 error probability, alpha, we are going to show that with alpha, we are going to call that significance level. All right, that's another term that you need to know. Significance level, type 1 error probability. Now, let me record one more video for moving forward. We are going to talk about designing different tests, and the most importantly, we are going to talk about p-value.